So we've already talked about how economics is the study of how people choose to use scarce resources. And we've defined scarcity in the economic sense as having limited resources in the face of unlimited wants. And we talked about how, because we have these scarce resources, that leads to this question of how best to allocate those scarce resources. And we talked about how to do that using marginal analysis. But we actually skipped over another important concept that this scarcity leads us to consider, which is the fact that because resources are scarce, because we have these unlimited ways of using the resource, but we have to kind of pick, once we pick a way to use that resource, that's it. That leads to the concept of trade-offs. So that's where we're going to focus our discussion today, is trade-offs, what that means, and why that matters for decisions that we make. So scarcity leads to trade-offs. Since we can only use our limited resource for one of the many unlimited wants, once we make that choice, we are giving up all other possible uses for that resource. It'd be nice if we could kind of get a way of measuring the fact that scarcity leads to trade-offs. And the way that we measure these trade-offs, the way that we assign a value to these trade-offs, is by defining opportunity cost. You've probably heard of opportunity cost. It's become something of a catchphrase in modern culture, but it's not always used correctly in the economic sense. So the accurate economic definition of opportunity cost is the value of the next best alternative. So of all these different unlimited wants, what's the next best thing that we could be doing with this resource? The value of that next best thing is the opportunity cost. We do the value of the next best thing because that value usually has a number associated with it, and that number tends to be a dollar value. So that allows us to make comparisons between opportunity cost with this dollar value to like a normal cost, like how much do you pay for a ticket or something. So that's our definition of opportunity cost, is the value of the next best alternative. Let's talk about why this concept of trade-offs and the way that we measure trade-offs using opportunity cost is so important for decisions that we make. So you guys are enrolled in college at Utah Valley University. There are certain costs that you have paid or are paying to attend and consume your education at UVU. So most of those costs that you probably are in your head right now are what we'd call explicit costs. You have actually paid money for them. So like your tuition, books, maybe room and board if you had to move to Utah Valley to attend the university. Those are all things that you have to pay for explicitly. But we can also think of your opportunity cost of going to college. This time that you spend in class or doing homework, studying, you could be using that time for something else. And again, time is a scarce resource, so there's an unlimited number of ways that you can use your time. But for opportunity cost, we want to focus on the next best alternative. So what's the next best thing that you could be doing with your time instead of watching this video to prepare for class? I would like you to actually answer this question. I would suggest writing it down. There will be future quizzes and assignments that require you to understand and talk through opportunity cost, so it's good to practice it now. So pause the video, write down what is the next best thing that you could be doing with your time right now, other than preparing for class by watching this video. The value of that next best alternative is going to be the opportunity cost of this class right now. To make it concrete and easy to measure the value, you can think of your next best alternative perhaps as being working. If you have a job, you could be working right now instead of watching this video. I do recognize that since this is a video, you probably, several of you might actually be working and watching the video, but let's just pretend for ease of argument that the next best thing that you could be doing right now is working, and therefore the value of the next best alternative is the wage that you could be earning. So because you are here watching this video focused on preparing for class, the opportunity cost of the preparation is the wage that you could be earning. So if we kind of expand that to the opportunity cost of attending college in general, you are giving up a full-time job with a certain amount of pay in order to take some time to attend classes and get a degree. So in addition to the tuition and room and board and books and fees that you have to pay for, there's also this opportunity cost associated with getting a college degree. Which leads us to a specific example of this type of opportunity cost that is interesting to consider. This is LeBron James when he was in high school. And many of you know that LeBron James went straight from high school to NBA, so he did not get a college degree before becoming a professional basketball player. If we were to analyze that decision from an economic standpoint using this opportunity cost concept, we might ask, well, if he had chosen to go to college, he would still have had tuition and fees, although he probably would have gotten a scholarship, so it might not have been all that expensive in terms of how much money he would have to pay. But what's his opportunity cost of going to college? His next best alternative was to sign with an NBA team, and his base salary for that first year in the NBA was $4 million. So even if going to college would have been really cheap because he would have a scholarship, he would have given up $16 million for 4 years of college because he couldn't play in the NBA while in college. So his opportunity cost was much higher than his explicit costs, and so it kind of makes sense that he would choose to go straight to the NBA rather than go to college first. So that's an example of how opportunity cost can start to affect our decisions, even if we don't necessarily give it that name. We kind of inherently recognize or intuitively recognize that opportunity cost, that we're going to be losing things if we make certain decisions. Let's do another example that has interesting implications for what we see happening in the world. So this is a picture of Shakespeare in the park, in Central Park in Manhattan in New York City. Every summer they put on a free Shakespeare play. I think that since the pandemic in particular, they give away the tickets all online. So this system is different. But when I was younger, I would go to visit New York City occasionally in the summer with family, and we would sometimes try to get these free Shakespeare in the Park tickets. And the way that it worked was that the box office would open up I think the box office was around here or something, in Central Park, and it would open at 10 a.m. the day of the show, and it would be first come, first serve. Whoever was in line for the tickets first would get the tickets, and then once the tickets ran out, you'd be out of luck for that day. So these Shakespeare in the Park plays are really well done productions. They often have famous people acting in them. And so tickets tend to be pretty popular. And so one summer, I remember getting up at 5 a.m. to go line up for tickets for Shakespeare in the Park. But the line was already so long that it was out on the border of Central Park. So it was already so long that it was out the park, and we were basically on the sidewalk waiting, and we definitely didn't get the tickets for that day. Some people, we were told, had been waiting since 2 a.m. or so. So my question for this example is, considering the opportunity cost of this free ticket, who would you expect to see in line for these tickets? So it's a free ticket, but even stuff that's free has an opportunity cost. And in this case, the opportunity cost of this free ticket is the next best alternative of what you could be doing with your time between 2 in the morning and 10 a.m. So for a good portion of that time, the next best alternative is probably sleeping. But for the morning hours, the next best alternative you might think of as going to work. So again, once again, it's kind of, you can think of the opportunity cost of this free ticket as the wage that you could be earning instead of waiting in line for the ticket. So now I'll ask again, who do you expect to be waiting in line for those tickets? Who has the lowest opportunity cost of waiting in line for those free Shakespeare in the Park tickets? I invite you to pause the video once again to consider this and maybe write down an answer. So I was a tourist. I was there on summer vacation, so my opportunity cost of time was low. So it made sense for me and others like me to be waiting in line. I also noticed that there were a lot of students, because even if the students had a job, it was probably a part-time, relatively low-paying job, or they might have just had class that they could skip at fairly low cost. So, and then I would also see more like older people who were retired or on vacation or whatever. So the people I didn't see in line for Shakespeare in the Park tickets were like Wall Street bankers and lawyers, the people who work in New York City with high wages. So we can see that once again, opportunity cost is there in the background, affecting who's waiting in line and who's getting those free tickets. But then you take it one step further. So yes, those are all the people waiting in line for the tickets, but who do you think you actually see at the shows? You probably do see the high-powered lawyers and the Wall Street bankers at the shows, because the students in particular are going to turn around and take their free tickets and sell them online to whoever wants to pay for them. So it's once again, opportunity cost and incentives make a big difference in who shows up for the tickets versus who shows up for the actual play. All right, so these are some examples of opportunity cost and how they affect decisions and the way the world works. Now let's, similar to what we did, let's go back a little bit to our marginal analysis example that I did in the other video. We talked about making cookies, and I talked about how as the quantity of cookies that you eat increases, the marginal benefit of eating those cookies goes down. And I also argued that as the quantity of cookies that you make goes up, the marginal cost of making cookies goes up. And it kind of makes sense when you just focus on marginal cost as what you're paying for ingredients and things like that. But if we're just counting cookies like 3 versus 8, it doesn't actually make a whole lot of sense for the marginal cost to be increasing that much, because one batch of cookies tends to make with the ingredients that you already have, one batch of cookies probably makes like at least a dozen, if not more. So rather than thinking of marginal cost as purely just what you have to pay for, this argument of increasing marginal cost makes more sense when you think of it in terms of opportunity cost. What else could you be doing instead of making cookies? You could be working, you could be studying for school, you could be spending time with your family or friends. So let's focus on, again, just because it's easy, you could be working instead of making cookies. So you're going to choose to make cookies. You're going to choose to make your first cookie when you have a low opportunity cost of time. Maybe it's after work has finished, after school has finished, and so you have nothing really better to do. So you have a low opportunity cost of that first cookie. But the more time you spend making cookies, the more time you're spending on cookies rather than on other stuff like working or going to school that is more valuable. And so the more time you spend making cookies, the more your opportunity cost goes up. And so that opportunity cost might be a better explanation for why marginal cost is increasing rather than just the explicit costs of the ingredients, etc. So this illustrates an important point that when we talk about marginal costs or other costs, we're not just referring to what you have to pay for with money, we're also including opportunity costs in those cost calculations. So this is one way that we can picture marginal cost, is just thinking about including it in costs in general. But the best way to picture opportunity cost is by using the production possibilities curve. The production possibilities curve is a model that shows the maximum combinations of goods that a country or a person can produce with its given resources and technology. So a country has a certain number of resources and a certain technology available to them. The production possibilities curve is a model showing, okay, using all these resources and this technology, this is how much we can produce, the most we can produce with those resources. Let's go through an example of a production possibilities curve in order to see why it's a good illustration of opportunity cost. We're going to start by doing a production possibilities table, and then we'll show the actual curve in a diagram. So, and rather than a country, we're going to just look at one hunter-gatherer, one person who can either hunt rabbits or pick berries. So I'm going to use R for rabbits, B for berries. If this person spends all her time picking berries, she can pick up 300 berries and catch no rabbits. If she chooses to spend enough time to catch one rabbit, that means she has to give up some of the time she otherwise spent on berries. So there's a trade-off, right? If she spends time to hunt a rabbit, she's giving up some berries. And let's say she has to give up 20 pounds of berries, or whatever unit you want to use for these berries. If she spends enough time to catch 2 rabbits, she has to give up even more berries. Same for 3 rabbits, she can now only get 180 berries. 4 rabbits, she only gets 100 berries, and then 5 rabbits, that takes all her time and she gets no berries. So we can immediately eyeball that there's these trade-offs between rabbits and berries. If she spends all her time on berries, she gets 300, but if she wants to spend any time on rabbits, she has to give up some berries. So because there's these trade-offs that she's making, it's immediately obvious that we can calculate the opportunity cost of those trade-offs. But before we do that, just a reminder, this table shows the maximum combinations of rabbits and berries that this hunter-gatherer can produce, given the amount of time that she has in a day and her technology, which might be like a bow and arrow or something. So again, this is a production possibilities table, and now we can use this production possibilities table to calculate the opportunity cost. You can either calculate the opportunity cost of one rabbit or the opportunity cost of one berry. We're going to start by calculating the opportunity cost of one rabbit because that's a much more straightforward calculation. So let's create a new section of the table. We're going to calculate the opportunity cost of one rabbit. So for the first rabbit, how many berries does she have to give up? I would like to see if you can answer this on your own, so if you need to, you can pause the video. So we're going from 0 rabbits to 1 rabbit. How many berries does she have to give up for that first rabbit? So we just do 300 minus 280. The opportunity cost of one rabbit is 20 berries. And do be sure when you answer questions about opportunity cost that you do use the correct units. So the opportunity cost of one rabbit, of the first rabbit, is 20 berries. The opportunity cost of the second rabbit, now she's giving up 40 berries. Notice that we're looking at the marginal, the step-by-step opportunity cost. So we're not going from 0 to 2, we're going from 1 to 2. The book does call that the marginal opportunity cost, but I usually just refer to that as the opportunity cost without bothering with the marginal terminology. So the opportunity cost of the second rabbit, we're looking at how many berries you give up to go from hunting one rabbit to hunting two rabbits. See if you can fill in the rest of the table. I'll show the answers, but I won't talk through them. But again, you can pause the video and try to fill in the rest of the table on your own. So let's see if there's a pattern here. As we spend more time hunting rabbits, what happens to the opportunity cost of rabbits? It goes up. There's increasing opportunity cost as we spend more time hunting rabbits, which kind of makes sense. If you are hunting rabbits, that first rabbit is probably fairly easy to catch because the rabbit doesn't know you're looking for it. And so you don't have to spend all that much time. You don't have to give up all that many berries to catch that first rabbit. But as you hunt more and more rabbits, they're going to be harder to find. You have to spend more time hunting for them, finding them. And so the more time you spend hunting rabbits, the more and more berries you have to give up. So this is the pattern that we see in just the numbers. Now let's go ahead and see what that looks like graphically. I've prepared a set of axes here, so I'm putting rabbits on the x-axis is just the quantity of rabbits, and then the quantity of berries on the y-axis. I do recommend that you try to draw this production possibilities curve with me. You will see questions on future quizzes and assignments that require you to do production possibilities curves, so it's good to have practice with them. So if she hunts no rabbits, she picks 300 berries. If she hunts one rabbit, she picks 280 berries. If she hunts two rabbits, that's 240 berries. I'm going to try to be as accurate as possible here. 3 rabbits is 180 berries. 4 rabbits is 100 berries. And 5 rabbits is 0 berries. So if we connect these dots, I'm going to connect them with straight lines because that will make the next thing I want to do a little easier. We see that the PPC, the production possibilities curve, has this bowed out shape. Let's try to see why the PPC has a bowed out shape. In order to see that, let's calculate the slope of these line segments. So let's start by calculating this slope right here from 0 rabbits to 1 rabbit. Remember that slope is the rise over the run. It's the change in the y variable divided by the change in the x variable, which in this case is the change in the number of rabbits divided by the change in the number of, the change in the number of berries divided by the change in the number of rabbits. So in that first segment, we're going from 300 to, let me actually switch that. So it's x2 or y2 minus y1 divided by x2 minus x1. So it's 280 minus 300 divided by 1 minus 0. So that gives us negative 20 for the slope of this first line segment. The slope of the second line segment, I'll do down here. So we're going from 240 minus 280 divided by 2 minus 1. So that's negative 40 is the slope of that second line segment. Again, I encourage you to try doing that same calculation for the rest of these line segments. But I'm just, for now, just going to fill them in. So this one here is negative 60. Is that right? Nope. Yes. Negative 60, and then negative 80, and then negative 100. And you notice I kind of cheated there because these numbers are precisely the negatives of the opportunity costs that we calculated from the table. So that's a constant relationship that you'll see in every single production possibilities curve. The slope of the production possibilities curve is the negative of the opportunity cost of 1 unit of the good on the x-axis. So in this case, the rabbits are on the x-axis, so these slopes are all the opportunity cost of 1 rabbit. And because there's increasing opportunity cost, that's why we see the slope increasing as we spend more time hunting rabbits. Most production possibilities curves have this bowed out shape, meaning that in the real world, we expect that there is increasing opportunity cost. The more and more we spend on one activity, the higher the opportunity cost gets. It should sound familiar, right? Increasing marginal cost. As quantity increases, marginal cost also increases. So it's the same kind of idea. The more we spend resources on producing one thing, the more we have to give up of the other thing. If this were a straight line, if the production possibilities curve were a straight line rather than bowed out, then the opportunity cost would be constant because that's just a constant slope, meaning that there's one opportunity cost. It doesn't matter where you are on the PPC, you're giving up the same number of the other good to get one more of the good on the x-axis. So you'll occasionally see constant opportunity cost production possibilities curves. So one thing to realize with this diagram is that the slope is the opportunity cost of this good that's on the x-axis. Questions on future assignments might ask you for the opportunity cost of the good on the y-axis, in which case you just need to do the reciprocal. So for this first line segment, because the opportunity cost of 1 rabbit is negative 20, that means that the opportunity cost of 1 berry is 1 over 20. Sorry, not negative. We express opportunity cost as a positive number. So you have to give up 1/20th of a rabbit in order to get 1 berry when you're on this segment of the production possibilities curve. So you just take the reciprocal of whatever's of the slope to find the opportunity cost of the good on the y-axis. You can do that same thing with the table here. So because of how the table is organized, it's easy to calculate the opportunity cost of 1 rabbit as we go down the table. You can also say that the opportunity cost of 20 berries is 1 rabbit, but that doesn't allow us to do easy comparisons. The easy comparisons aren't always done when we're looking at one berry versus one rabbit. So that's why you would need to, again, do the reciprocal. If the opportunity cost of one rabbit is 20 berries, then the opportunity cost of one berry is 1/20th of a rabbit. So you just, again, need to take that reciprocal to find the opportunity cost of one berry. So again, on future assignments, make sure that you are paying attention to those units and making sure they are comparable. So that's all that I'm going to cover for opportunity cost and production possibilities curve in this video. There's more to the production possibilities curve learning outcome that I'm covering in this video, so make sure that you do read chapter 1, and you can do the SmartBook assignment related to the production possibilities curve if you still need help. But we will see other types of questions on future quizzes, and so we'll have opportunities to go through those together as we see them in quiz questions, etc. Once again, if you have any questions or concerns about these topics that I've covered, please let me know.